Greetings. Was asked to take a look at problem 9. You try characteristics of exponential functions from lesson 5. Okay, so complete the table. Start by graphing each function with the indicated viewing window. Sketch what you see on your calculator screen. So the question was, how do I do the calculator? So let's go ahead and get a calculator up here so we can actually do that. So let's clear out all the craziness I have here. Hit my y equals key, which is the first key in the upper left hand corner. And we need to put in 335 parentheses 1.25, close the parentheses, and then caret x. Cool. Now, if you just hit a zoom and a standard, you'll get back negative 10 to 10, negative 10 to 10, and you will on the window, and you will not see the graph. Well, they gave us viewing window instructions so that we will be able to see the graph. They said press your window key. In other words, use this following window setting and set x min to negative 10. Cool, that's done. X max, set that to 10. That's done. Y min, they said set that to 0. Y max, they said set that to 1,000. And then to avoid getting a bold-faced y-axis, we're going to set y scale to 100. If we leave that at 1, that means they're going to have 1,000 tick marks on there, and it's going to look pretty crappy, so we don't want that to happen. Okay, so now we just press graph, and we get this stunningly gorgeous graph on our window. So we're supposed to come over here and make a sketch of what we see. So our graph looks not quite unlike, but similar to that, where that's our x and that's our y. Okay. All right, now they ask us to do the same thing, but this time change the function. We don't have to change our window, which is kind of nice. So let's go change our function to, clear this one out of here, 120 parentheses 0.75. So we can see already this is going to be a decay function because the base is less than 1 raised to the x power. Don't mess with the window this time and press graph, and sure enough we get an exponential decay function. So we're going to come over here and draw ourselves an exponential decay function. There's my x, there's my y, and my function looks not quite alike, but similar to that. Now remember that the x-axis is playing starring role of a horizontal asymptote, so our function does not touch that axis. Okay, now I was not asked to do the remaining problems, but I'm going to do them anyway. Okay. All right, so what was the initial value a? Well, we know that all of these functions are the form, or these two that we're looking at, f of x is equal to a times b raised to the x, where a right here, that's our initial value. So in the first one, our initial value was 335, and our second function was 120. The base b in the first function was 1.25, and the base b in the second function was 0.75. What was the domain? I love the domain of exponential functions. It's negative infinity to positive infinity. It's the I want it all domain. Whoops, my bad, excuse me. Pardon me, backing up here. Why? Because they asked us to use inequality notation. So let me go back. I'm so happy with my interval notation. I forgot to say use the inequality notation. So it's negative infinity is less than x, which is less than infinity in inequality notation. Still got to get my infinities in there. Range, use inequality notation. Okay, so the range, part of the reason they want us to do inequality notation is we have to show the variable that we're talking about in inequality notation. So notice in the case of the range, we're talking about y. It's y strictly greater than 0 in both cases. Okay, horizontal intercept. Where does it cross the x-axis? None. It does not cross the x-axis, because what we just said is that the x-axis is playing the starring role of a horizontal asymptote. And so it's going to come down and get as close as you ever want it to the x-axis, but it is never going to touch it, okay? So in both cases, it's a none. There are no horizontal intercepts. What about the vertical intercept? Well, go consult A, because if you take a look at f of 0, you're going to get back a times b to the 0 power, which gets me a times 1, which gets me back a. In other words, the order pair 0a will be our vertical intercept. So you just got to look for a, and you've got the vertical intercept. So in our first case, we see our vertical intercept is going to be at 0 by 335. And in the second one, our intercept is going to be at 0 by 120. Horizontal asymptote, write out the equation. Well, what is the equation of the x-axis? That's y is equal to 0 is that horizontal line. And then last but not least, we want to know if it's increasing or decreasing. This is a growth exponential function or an increasing exponential function, where this one is a decay or a decreasing exponential function. Well, hopefully that was informative and helpful. If not, please let me know and I'll see what I can do to make it better.